systems of linear inequalities. So we've been talking about systems of linear equations for a while. Now, the slope-intercept form, hopefully you remember from geometry, y equals mx plus b. So just remember m is our slope, and that is rise over run. And our y-intercept is the b value. I mean, if you think about it, that is our starting point. That's our starting point of every graph that's a linear equation. So we have y equals mx plus b. We have our slope, rise over run, which is m. Our b value is the y-intercept. In order to graph, we must solve for y first. Solve for y first. Okay? All right, we've had inequalities before, so just a refresher, we have our symbols less than or equal to, greater than or equal to. So when it's less than, our line is dotted. Less than or equal to, it has, it's solid. So greater than, dotted, greater than or equal to, solid. Shading, the direction it goes, low, below, above, above. So simple enough. All right, so we have y is less than x minus 3. So that means our y-intercept is at -3, and our slope is 1. So we're going up 1, up 1, up 1, up 1 and over 1. And it's going to be a dotted line. So I'm going to put these dashes in between my points. And it's less than, so that means we shade below. So shading doesn't have to be perfect, but I just want to see it in here. And then we have y is greater than or equal to x minus 4. So for x minus 4, we're at -4, and then we're going up 1 and over 1. So these have the same slope. This one is solid because it is greater than or equal to. So that means now we're also shading in here just like the blue did, but we also have everything up here is all red. So looking at it, our solution is the part in there is the between the two lines, between the solid red and the dotted dashed blue line is our actual solution. All right, so let's flip over our page. And let me get this set, gotta do some finagling. Okay. All right, so we have 3x plus 2y is less than 4. So I'm going to do this in green. So we need to get y by itself. So that means it's 2y. I'm going to subtract 3x from both sides. Minus 3x plus 4. Then I need to divide everything by 2. So y is less than -3 over 2x plus 2. So I'm going to graph that first. So my y-intercept is at 2. It's That's where I start my graph, and my slope is down 3 and to the right 2. Down 3 and to the right 2. And it is less than, so that means it's going to be a dashed or dotted line. And it's less than, so we would shade below it. Okay. We have our other equation, which is 4x minus 2y is 6. So I'm going to make that minus 2y is less than or equal to negative 4x plus 6. I subtracted the 4x. Then, when you divide by a negative, you need to flip the inequality. So that makes this 2x minus 3. So our y-intercept is at negative 3, and we're going up 2 and over 1. Up 2 and over 1. And it's going to be a solid line. And in this case, we're shading above it, so this area right here is just red. But then this area is red and green. All that is red and green, so that's our solution. All right, final one. So we'll do yellow, or y is greater than or equal to negative 1/2 x plus 2, so our 2 right there, and negative 1/2 x, so it's going to go down 1 and to the right 2. And it is going to be a solid line because it is less than or equal to. So we'll do our best graphing it, and it's going to be above it, shading in. So there's our shading for the yellow part. And the last second one is y is less than 2x. So let's put it in blue. So 2x, the y-intercept is at 0. And it's going up 2 and over 1. Up 2 and over 1, and it's going to be dashed. And so we're going to say it is less than, so this whole part here is just blue. And then this part is blue and gold. So that's where our solution is at. So now we have to look at our number. We want to know which ordered pair is a solution. 9, 3. So we go out 1, 2, 3, 4, 5, 6. 9, 3 would be like right there. We would say yes, that would be in the solution set because it would extend there. -8, -8, it's going to be down there. Down there? No. 2, 4. 2 up to 4. Right there. This one is a tough one. It's on the blue dashed line, so that means it's not part of the solution. 7, 2 right here. That one definitely is in. -1, 6 right there. Not in. 5, 5. That one is easily in. 2, 1. So 2, 1 is right there on a solid line, so it is in. -4, 0, not in. -1, -2, not in. And then you can create your own solutions and not solutions. What part of the shading represents the graph solution to the system? Where both, it's the overlap. We say the overlap. And that is systems of linear inequalities.